we are. So all of that, we just spent an hour and a half on, the stuff we already knew. Right? But hopefully stuff that's now getting better, that's answering questions, that's going into the business question, getting you to think a tiny bit. Now you also have more fun stuff to play with the query builder, and you can dig in and have some fun. So where we are today is, how confident are you? That's our question for today. Okay. So let's explore for just a little bit more. I've been having fun in SAS, and we're going to stay in SAS for just a few more minutes. We've already asked the question, tell me about our sales for this promotion overall. Okay. You told me about the sales, right? We provided descriptive statistics. We've looked at a 5-number summary. We've looked at box plots, kind of telling us about our promotion. Okay, we're going to get into the interpretation piece a little bit more. But we've been using point estimates so far. We've just been using one number. Right? What was the average amount that we spent during our promotion? Or the average amount that a customer spent during our promotion? Okay. We could have looked at what was the average variability in customer spending. We just had one value. Okay. So if we use an interval estimate instead of a point estimate, does that change our story? The other question I have is, with that interval estimate, if we change the confidence level, how confident we are in the results that we're going to talk about, does that change our story? Right? So if I'm 90% confident versus 99% confident, does that change the story that I tell? So let's look. Let's explore a little bit. So first I'm just going to show you some SAS output. Then we'll go in and we'll actually see which buttons to click to make this happen. Okay? So we already have the mean, our point estimate, right? So if we have the mean, we can represent that with an X bar, right? Are we good with that? We have our standard deviation. We have our standard error. So in Chapter 7, we talked a little bit about a sampling distribution, and we mentioned the idea of a standard error. So our standard error of the mean, so it's a standard deviation and it has an X bar, kind of a sub X bar. We have our sample size, and then we created a lower and upper 95%. If we put this together, we can create a confidence interval. So we have a confidence interval from $155.43 to $161.42. Here in the middle is our sample mean of $158.42. That's kind of nice, isn't it? And then if we wanted to have even more fun, the way that confidence intervals work, we actually start out with the point estimate, and then we add and subtract a margin of error. So here, we have our point estimate, and if I want to be 95% confident about my mean being correct, my mean actually being what's happening in my population. I didn't do this math ahead of time, sorry. Oh, that's nice and easy. Is that easy? 3. So if I have this information, I can say we're 95% confident that the average net sales, because that's what I'm interested in, per person, for the entire population of Razorback Store customers is somewhere between 155.43 and 161.42. So what we're assuming is that the data we have are sample data. We're trying to make this inference to our entire population. I could also say We're 95% confident that the interval from 155.43 to 161.42 captures the true population mean of Razorback store customers' purchases during the promotion period. This italicized part, we are blank % confident that the interval from blank to blank captures the true population mean. You could write that almost every time to explain how a confidence interval works. Okay? There's other ways you can interpret it, but that's like, if you needed a go-to of how am I going to write this up, that's a stem you can use to write it up. So now instead of just saying that given the sample data that we have, on average our net sales are $158 per customer, now I'm saying that it's between $155 and $161 per customer. And that was for a 95% confidence interval. Is that really, because of that size of that confidence interval, does that really make you change your interpretation for your boss? Get a margin of error of $3. $3 really that big of a deal?
It depends on the units. It could be, in millions.
Absolutely, right? So if we're talking about purchasing, and I'm talking about kind of store overall, and my units is even thousands, right? A $3,000 margin of error could be a big deal. Here, if I'm talking about $155 sale or $161 sale, probably not that big of a deal. But yes, units makes it huge, right? And it also makes a difference for a company, right? So for a small business, if I have a $1,000 margin of error, oh my gosh. For a large business, if I have a $1,000 margin of error,
that's a good thing.
Yeah, sure, that's awesome. Way to go. Okay. So yes, so paying attention to the context definitely matters. So my other question was, depending on how confident I want to be, does that make a difference? So here I have, let's see, what I have here. I like number lines. When I talk about confidence intervals, I like number lines. Okay. So you'll notice my mean stays the same. I've got 158.42. 58.42. And if I'm 90% confident that my true population mean of my entire population is going to fit in this interval, I'm going from 155.91 to 160.94. That's me being 90% confident. And if I want to be 95% confident, which is what we just had, I've got 155.43 up to 161.42. And if I want to be 99% confident, I've got 154.48 to 162.36. So what can you tell me about my confidence level, the percent that I'm confident, and my confidence interval?
You give yourself a wider range. As your confidence level increases, your confidence interval widens.
So if my confidence level increases, then my confidence interval gets wider. Sure? So if I said I want only, I mean, we're talking money here, whatever, it's just sales. If I only wanted to be 80% confident, the accountants in the room are like, we're talking money here. So if I wanted to be 80% confident, what could you tell me about the size of my interval? It's going to be smaller. I don't know exactly what it is without calculating it, but it's going to be smaller than that. So the more confident I want to be, the wider my confidence interval has to be. Kind of cool. Videos. How do you guys know what the Price is Right is? Some of you guys are like, yes. You're like, no. Price is Right. Let's see. If I click on this little YouTube link, what happens? I haven't tried this out yet, so what? It pops up in Microsoft Edge. Hey, jump in. Oh, gotta find the right mute button here. Mute.
Yes. Where are you from? Pittsburgh. And what do you do in Pittsburgh? I love it. It's not football season. During baseball season, I love everybody in Pittsburgh. I'm an artist. Yeah, you're an artist? Oh, how about that? Yeah. Hey, George.
So a customer is coming up on this game show.
This next prize, don't you?
They get to win prizes. A trip to Rome.
Is it all expenses paid?
I don't know. It sounds like a flight and hotel.
I mean, it's better than that. I'll take it. It's like that.
All right, so flight hotel to Rome. Oh, you get some things. You got to walk the floor.
Yeah, that's right. It's supposed to be city.
All right.
Here's the price.
Let's play a game.
Scale right here. All right. I don't know where it is up there. That's
Confidence interval,
round trip code for 2
range
people
game.
from Los Angeles to Rome. 6 nights. All right, 6 nights, 2 people. See this little red area right here? That represents $150 rates. It's going to climb up the scale. When you see the price of the trip to Rome in the red area, you're going to hit the button. If you're right, you're on your way to Rome. If not, then get your spinner wheel. Linda, you ready?
Yes.
Here we go. Start it up.
I love they never do it themselves. They have something to tell what to do.
Round trip coach for 2 people from Los Angeles to Rome.
This big area in the back.
No, you didn't do it. You can kick it, you can punch it. You can't break this game. This game's been around for like 27 years, something like that. Been around for a while. You're not going to hurt this game. You're from 9,200 about all the way up to 9,350. So a little over that. Let's see if you're going around. Ready? 1, 2, 3.
All right. So what just happened?
You got like
She got what just happened?
Using her $150 confidence interval, she got a free trip.
There you go. Okay. So we had $150, right? Was the range that she had to play with. Okay. Oh no, well sorry. Okay. So what happened?
the actual price was within her confidence interval.
So who knew the range game was really a confidence interval, right? So what margin of error did she have? If it was $150 range, then she had a $75 margin of error on each side of, like, so she could have picked a value, and then she had the chance to get $75 on each side of that value. Fun? And she got it. See what else happens. Got more. Let's watch another one.
Where are you from? Victorville, California. Wow, welcome to the big city. Nice to have. What are you doing in Victorville?
I need you to tell Clint he's hi for me.
Okay, hi, Clint. He's a fan. What do we have for Echo?
You gotta have fun. You gotta see what the prize is, so we don't want to do
Manufacturing a 14.8-inch ultralight RV designed for.
We'll skip the details of the argument.
And here's what we're going to play the range game.
We're gonna play the range game again.
This little red area is going to keep going.
Confidence interval,
Slowly.
$75 margin of error.
The price of the
What do you think happens?
Get me the range that's represented by
Well,
the
there was a little spoiler in the bag.
right in the trailer. That has your name on it. That has to be your trailer. It's an Echo trailer.
Gotta
Your
work
name
on
is
those
Echo.
animations.
Okay, ready? And start going up. Whenever you're ready, press the button. The $150 range. Right now, the highest price is going to be $17,100. On its way on up to $17,200. Lowest price $17,000 right now. Right in the middle, practically.
The arcade
Scale.
starter.
You're right, almost to 17,100 is a low, and 17,240 or something is a high. Let's slide it up and see if you win. Gosh, are you kidding me? Echo, you were off by like $2. That kills me. Showcase showdown, come on back, don't go away.
You didn't know it was that close, did you? So yeah, so same idea, confidence interval, you're in it or you're out of it, right? And we all talked about, so the idea behind a confidence interval, it's all about the true population parameter, okay? So what it is not, it's not the probability, or it's not how confident you are that the sample statistic is in your confidence interval. It's how confident you are that if you did this a whole bunch of times, this number of intervals would capture the true population parameter. So why are we talking about population parameters and not the sample statistic?
Population parameters fall wherever they're actually trying to find out.
Right, we're doing these inferential statistics. Right, we're trying to figure out about the population. What do we know about the sample? Do we know what the sample mean is? Yeah. How do we calculate? I haven't shown it to you yet. But how do we calculate the sample, or how do we calculate the confidence interval? Right? The equation starts with the sample mean. So how confident are you that the sample mean is in the confidence interval?
100%.
I'm 100% confident that the sample mean is in my confidence interval because I use the sample mean to create my confidence interval. I know I kind of beat this a little bit at the beginning, but you'll mess up. Don't worry. Nothing to worry. But the whole idea behind the confidence interval is we're trying to capture that true population parameter. That's why we're not just using a point estimate. That's why we're using an interval to give us a better idea of where that population parameter actually lies. So if we talk about the Price is Right, what would happen to the rate of prize winning if we shrunk the bar? So if our margin of error wasn't $75, but was $25. So how many people say, so we're going to shrink our margin of error, we're going to have a narrower bar. How many say we're going to give away more prizes? How many say we're going to give away less prizes? Okay, so we're giving away less prizes. Right? So very few prizes are going to be won. Statistically, our smaller confidence interval, the less likely we're going to get that population parameter. I'm not going to read all this. You guys have access to these. about if the bar was wider? Right, so now I'm giving away more prizes, right? Because it's going to be easier to get that. So statistically, we have that larger confidence interval. There's a higher probability we're going to get that true population parameter. Okay, so our confidence level is increasing. So if I'm a contestant, what size bar do I want? Like everything. Okay, and if it's the show producer, which size bar do I want?
Like, I think some people win. No one ever won.
Exactly how it is right now. So I got some people saying smaller, because fewer people win. Exactly how it is.
Well, but you want it kind of. You don't want it super small because then no one wins. It's like no one.
They need
wants
false
to
hope.
play. Yeah.
Right. So you don't want it too small, but you don't want it too big. So you probably might, I don't know, like hire a statistician to like come up with like a good like 90% confidence interval. Right? I mean,
We never thought of applying there.
do what?
We never thought of applying there. We should.
See? Oh yeah. Oh, you could totally beat this thing. A little bit of research. Yes. Oh, apply there. Yes, apply for them. Who knew? Statisticians are everywhere. So there are some comments about it. So since large intervals are more likely to contain the population value, shouldn't all confidence intervals be as large as possible to make sure you calculation the population value? How many vote yes, we should make our confidence interval as large as possible? How many vote no? How many aren't sure? I love the honesty. Okay, so why not as large as possible?
Cost of information and time.
Okay.
It might become like meaningless.
Starts to get meaningless.
Yeah, it's not material.
Okay. It's going to cost me to get that information. It's not going to make sense as much.
It's the same as the Garfield comic. You don't really get anything out of something that is that broad.
Excellent, right? So it's like, yes, you're going to get the temperature right, but who cares? I know it's going to be, like, that doesn't help me decide what to wear today. So the same kind of idea, right? So if we're talking about college students, I know I'm going to get everybody between the age of 4 and 100. I don't know. I graduated with a guy, or a lady, who was 83. She was awesome.
That's awesome.
But yeah, but really, I can be 100% confident that they're going to fit in this, or I can be 95% confident they're going to be between 18 and 22. Right? Yeah, so we're just going to note there's a trade-off between the degree of certainty and the width of the confidence interval. Right? So the more certain we want to be, the larger the interval needs to be. We already kind of discovered that.